and reshare. Right. Okay, I think I'm organized now. Good. Okay, so IPv4 and IPv6 addresses. Array button, click in. Okay, so this is what I thought we would be useful to talk about. First of all, talk about Internet Protocol version 4, bit of an overview and its main stumbling block, its big problem that it has, and then move on to talk about IPv6 and of course an overview and its advantages. Now today I don't have a huge number of slides, so I've got two screens here, so do feel free to interrupt me or stop me if you've got a point to raise as we talk through this. So, yeah. So here's a little example network. Oh, let's actually let me start with this. So, Internet Protocol v4. Now, this was actually created around 1982, so it's pretty old. And this is about every device, every computer on the network has to have a unique address. If you've got two computers on the network with the same address, in the same way as if you've got your street and you've got two house numbers with the same number, it's not going to work. So each device has to have a unique address on its network. Fundamental principle of networking. So just to give start off what this looks like. Google. Google has got an IP address of 142.250.72.142. So a v4 address is of this format of four numbers separated by dots. And likewise, Glastonbury Festival site has got an IP address of 45.223.57.82. My server has got an IP address of 145.40.187.76, and so on and so forth. Every device on the internet and local networks has to have a IP address. And this is version 4 of the Internet Protocol addresses. Now, of course, oh yeah, let's do that. So if you don't know what your desktop IP address is, there is sites to show that. So you can go to these web addresses. And here's an example. Hopefully you can see this. This is, IP info, and it tells you what your public IP address is. So you can always look up what your public IP address. Yeah, Ray, go ahead. Unmute first.
Yeah. How does this compare with the Mac number or Mac address, you call it?
Good.
Device?
So I wasn't going to talk about that, but since you mentioned it, so every piece of hardware which is connected to the network has a physical, what's called a MAC address, MAC, unrelated to a MacBook or Mac OS. And I think it stands for Mandatory Access Control. And usually these numbers are physically printed on the device somewhere. And in theory, those MAC addresses are, again, unique. They are actually specified when your Ethernet card or your Ethernet device is manufactured. So that's one thing. Today, though, we're talking about IP addresses, which is something at the software level rather than the hardware level. So if we go back to our slides, so you can always just find out your own IP address on the internet by going to one of these sites here. However, of course, when you're surfing the net, you fire up your web browser, you don't type in, if you want to search Google, you don't type in 142.250.72.142. You type in google.com. So there's this service on the internet called the domain name service, whose purpose is to map between these user-friendly names like google.com, glastonburyfestival.org, and so on into a IP address. So if you fire up your web browser, you type in google.com, what's going to happen is your web browser is going to do a DNS lookup first. It will translate google.com to its IP address, these four numbers, and then your browser would make a connection based on that IP address. So again, let's have a look at DNS since I've mentioned it. Here we go. So got some tools on the internet. We can do a DNS lookup. So I don't know, google.com. We can do a DNS lookup, and this tool will convert this name, this text, to its IP address. And in fact, google.com and many big sites have multiple IP addresses. And you can see that on this side here. You actually got, and the reason for that is if one of Google's servers goes down, your browser will just simply connect to an alternative site. So one reason is resilience. Another reason is load balancing. So if you've got a web server that's got many IP addresses on across many servers, then all the different users accessing that server would roughly equally use all those available servers. So there we are. So DNS will map from user-friendly name, and we can do, my server, plaw.co.uk, and we've got, my IP address, which is registered in DNS. Ray, go ahead.
What's to stop people spoofing those IP addresses?
DNS, the various authorities that manage the domain name service, you have to buy a domain to be able to do this. So I've purchased plaw.co.uk, and that act of purchasing gives me the ability to edit my DNS records. No one else can edit that DNS record, so only me. So that the plaw.co.uk belongs to me personally, and I can play with that. And in fact,
Sorry, what about the IP address though?
if you want to, you can change the IP address on your desktop. You can change your IP address, be the same as mine. You can, you just need administrative rights to do that. Networking will then fail. So it'll be exactly the same as, if you've got two addresses on your street and the postman will get very confused. So absolutely, you can have multiple IP addresses on the same network, but it's not going to work very well. Okay, so let's go back to this. So, oh yeah, there's good. MX Toolbox is a good site. It's one that I showed you just now, and it's a good way to explore IP addresses. Now, interestingly, there's aside from DNS, there's additional databases who like to try and figure out more about your IP addresses, particularly things like who owns the IP address and where is it physically located and such like. But these are very much unofficial databases, so they're often wrong. I'll give you an example there, but let's yes, no, oh yeah, here's an example. So I can put an IP address in here. I can do a lookup, this particular one. And what this server is trying to do is trying to really guess where this is the IP address of my server, which is in a cupboard next door to me. And there's a service called IP to location, thinks I'm in, where am I in? UK, that's about it. Oh, in London. Fine. This one thinks I'm in Wokingham, which is correct. This service thinks I'm in Wokingham. This one thinks I'm in Aldershot. So there are lots of these different databases trying to figure out where you are. So one example, for example, so I've got a Amazon shopping account, which I share with my wife. And every so often I get alert on on my phone saying that my wife's logged in from Southampton because Amazon is trying to figure out where my wife is by doing this location mapping, but it's never very accurate. So this is unofficial stuff, but commercial companies like to try and guess where you are. Okay. Uh, right. So each device on the network can and will have multiple devices. So my MacBook here will have an IP address that enables me to talk to other machines on my local network, but it also has some other addresses. So, for example, it's got what's often called a local host or a loopback address, which is always 127.0.0. Something, often .1. It can be 0, it can be 6. And there's also this special address which allows you to broadcast to the whole network. So I mention this as a detail, but it means that if you've got a range of IP addresses that you want to use, some of them will be reserved. So here's some screenshots. I've already showed you this. This is the MX toolbox that allows you to do a DNS lookup. And in this case, we get lots of IP addresses, IPv4 addresses back. And this is an example of mine. An example here of a website that tries to display your own personal IP address as far as that web server receives it. An example of trying to figure out the location. This screenshot thought I was in London, which I wasn't. And this is a desktop screenshot. So this is my Mac. This is the network configuration. And it's the same with any operating system, right? So I can go into TCP/IP settings and I can see the IPv4 address that's been allocated to my desktop machine. And this is my Linux server. Linux tends to be give you more useful information, but sometimes a bit more oblique, perhaps. So here we can see that this particular Linux server has got an IPv4 address of 192.168.175.12. And it gives you a lot more information about some additional metadata related to that IP address. I've got a Windows example a little bit later. So every device on your network's got an IPv4 address. So let's dig in a little bit what an IPv4 address looks like. So as I mentioned before, there are 4 digits, 0 to 255. So you can have 0.0.0.0 all the way up to 255.255.255.255. And that gives us 4 billion unique addresses. Some are reserved, so you don't quite get the 4 billion usable. And as before, each device on a network must have a unique address. You can certainly create duplicate addresses, but it ain't going to work. Now, IP addresses on a particular machine can be manually assigned. So you can go into your, computer network settings and actually type in the IP address that you want to use. But far more commonly is that IPv4 addresses are automatically assigned by some device on your network. And those protocols is back in the day, there was a network protocol called BootP, the Bootstrap protocol. These days, pretty much everyone uses DHCP, Dynamic Host Configuration Protocol. And so I would guarantee, pretty much, unless someone corrects me, that you at home, you've got a router which is giving you access to the internet. And on that router is running a piece of software called a DHCP server. And that is responsible for allocating IP addresses on your local network. We can have a look at mine. If you're interested, I'll show you my router and you can see the configuration of that DHCP server that I'm using. Yes, that's what I just said. So that's basically it for IPv4 addresses. Now, actually, I'll do this. I've got a couple of slides in the wrong order, so I'm going to go back in a minute. I want to introduce you to this, what's called classless interdomain routing notation, CIDR. So an IPv4 address is actually split into two parts. There's a network part and a host part. And so devices that have the same network part of the IP addresses can communicate with each other. So a physical network can actually have multiple networks, multiple addresses, and they can be logically separate. Now, the way these are expressed is with a slash and a number of bits. So, for example, my home network is 192.168.175.0/24. And what that means is 24 bits of the IP address is used for the network part, and the remaining 8 bits is used for the host part, which means my home network can have a range of IP addresses of 192.168.175.1 all the way up to 254. So this CIDR notation is giving you an indication of the allowable IP addresses on your network. And the special one of .255 is used for a broadcast address. So sometimes applications want to send a message to all devices on your network, and the 255 will do that. I'll send a broadcast address. And in fact, DHCP works by broadcast addresses. Sometimes if you want to manually configure IP addresses, you can typically do it either this way or you give it a subnet mask instead. But really, most configurations I've seen recently have been using this sort of terminology. So I'm just going to skip back a bit to a previous slide because I missed this. So this is actually my home network, just to kind of put those ideas into concept. So we know from our DNS, we know from our DNS that google.com has got an IP address on the public internet of 142.250.72.142. And this is the internet, worldwide internet, in particular, my ISP. And I've got a router, it's downstairs and it's plugged into fiber and so on. And my ISP had given me a IPv4 address, and that is, we've seen that before. Now, on my home network, though, I can do what I like on my home network. So my home network, I've got an address range of 192.168.175. I manage this network myself, and the router will actually translate between anything on I want to do in here and route it out to the network. And we'll come into this more details a little bit later because there's a little bit more to it. So, but there is a problem, and I don't know if you've spotted this already, but there is a problem. But I said that with IPv4 addresses, there's 4 billion IP addresses in that range, effectively 0.0.0.0 to 255.255.255.255. But we've run out. The world has run out of IPv4 addresses, and this is a big problem. Now, one way we are really working around this problem is by a mechanism called network address translation, or NAT. And I want to make it clear that the people who wrote the standards on the internet, back in the 80s and 90s, NAT is very much a workaround to try and fix or work with this limit of IPv4 addresses. And techies really hate it. They really, really don't like it because it violates the whole principle of how networking was developed. It may not even work for some protocols, and it certainly doesn't work if you want inbound connections. But having said that, your router at home will support NAT. It'll have some settings specific to it, and it will do this network translation so you can have any number of IP addresses on your home network with only consuming one IPv4 address on the internet. Now, these days, of course, with the IPv4 addresses getting even scarcer, ISPs are starting to use what's called carrier grade network address translations. And I've got a diagram of that in a minute. And I sent that techies hate this NAT. Techies even more hate carrier grade NAT. And it does impact particular class of users. If you're a gamer, for example, you will be going to get your internet connection from a company who doesn't use CGNAT. So say some types of gaming, voice over IP, even video hosting really gets really hard to work with a CGNAT. And yeah, we got a little diagram of that, but this is a timeline. All right. So IPv4 was created back in 1981 with these 4 digits of, and it didn't take long. In fact, I'll keep going forwards. In fact, in June 1992, there was this first description of running out of these IPv4 addresses. But savior was there because there's NAT was proposed in 1994, and 1996 actually IPv6 was invented, which we're going to spend more time talking about, which is the real fix for this exhaustion of IPv4. And in fact, in 2011, it was officially declared that we are out of IPv4 addresses. So let's have a look at this NAT workaround. I'll keep calling it a workaround. So you can go into a router at home and you can see all the NAT configuration settings. So the way it works is if you're at home on your desktop here, you fire up a web browser and you go to google.com, what happens is you will make an outbound connection to google.com, which goes through your router. And then Google.com will reply with a web page, and it will reply with your web page, and your firewall is going to do this mapping. The thing is, when Google replies with the response, it only knows about your public IP address. So Google will give a reply, it will come back to this IP address, but this NAT software in your firewall will say, oh, hang on, this is part of a session. I'm going to tie the two parts, the outgoing and incoming part together, and I'm going to send that response from Google back to the desktop. So what actually happens in practice is you buy a router, it has NAT on it, you fire up a browser, and it just works. However, your firewall is doing all this NAT mapping. It's actually quite a lot of work. It's actually maintaining a database of all your inbound and outbound connections, mapping them together, and doing work. And if you're doing a lot of work, these routers get quite hot. This is not a trivial thing to manage. So if you look at your next door neighbor might have a public IP address, which is slightly different. So all the IP addresses on the public internet have to be unique. So this one's unique, these two are unique, Google's unique, so we're good here. But next door could, of course, have exactly the same internal IP addresses as you do. And that's perfectly okay because the NAT software on your router will take care of it. Providing you've got a unique public IP address, the NAT in your home will do the right sorts of things. So actually it works, this NAT, but it's a workaround because we've run out of IPv4 addresses. So it means that, every person just needs one IPv4 address. Even if they've got 2 million devices at home, they still need just one public IP address. Right, so let's take this a bit further and have a look at carrier grade network address translations. So in this case, the ISP will assign you, so whether it's Virgin Media or City Fiber or whoever it might be, they will assign you private IP addresses. These 10 addresses are not usable on the internet. So your ISP will just have one IP address, one public IP address for all its customers. So obviously that's going to save a lot on public IPv4 addresses, but the problem is that when you're on your desktop, you fire up your browser, you go to Google, your browser is going to send the package to your router is going to do the NAT mapping, it's going to go to your ISP is going to do CG NAT mapping, and then before it goes out to the internet, and of course, both these stages need to do mapping back. So now you've got two levels of this NAT mapping, and techies hate hate CG NAT even more than that. You can see now we've got two hops out. Again, for most users, this will work. Many users will not even be aware they've got CG NAT. They just sign up to fiber broadband and they install the router that gets delivered and it all just works. However, yeah, the odd user think, hang on, my voice over IP is not working very well. Inbound connections aren't happening. So these two, I'll say it again, these two techniques, NAT and CG NAT, are very, very common, but they're workarounds to try and to fix this problem that we run out of IP address. The correct way that we all should be using is, of course, IPv6, the Internet Protocol version 6, which was created a long time ago, 1998. So it's not new. It's not new. But this is what it looks like. And I guess, many of us will be familiar with IPv4 addresses, but probably a lot less familiar with IPv6 addresses. So let's look at this. So instead of having 4 digits for an address which IPv4 has, IPv6 has 8 digits. And instead of each digit being between 0 and 255, each digit is between 0 and 65536, which actually gives you 128 bits. So if you look at all the possible IPv6 addresses, you get this really big long number of possible addresses. And I had to look it up. There's 340 undecillion addresses. So whereas IPv4 was 4 billion. And this is, a huge number. Now, some of these IPv6 addresses are reserved, but we've got quite a few. We don't care. And it's enough for every device on the internet, public or private, to have a unique address. Easy enough. So what do these look like? They're written in hexadecimal with a colon of a separator. And there's a IPv6 address. We see we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. Each are like 4 hexadecimal digits and are separated by colons. Now there is a short form, zeros. See, we've got a list of zeros here. And so those are not, so leading zeros are dropped. You don't need that one. And a trail of zeros are compressed into a double colon. So in fact, this address here is identical to that one. It's just a short form notation. So we've dropped a zero there and we've got a double colon there, which is a compression of all of those. Okay, and like IPv4, you can use DNS to map names to IPv6 addresses. And let's actually do that since I mentioned that. Go to address. Here we go. So we've got a option here which is AAA lookup. So let's do google.com. And we've got Google.com and we've got IPv6 addresses. So google.com hosts IPv4 and IPv6. And you can see this on double colon, which is simplification. So we can look at mine, if you like. And I've got an IPv6 address for my web server. There we have it. And yes, so in terms of DNS, the IPv4 lookup is called A records, and for IPv6, it's called AAAA records, 4As for some reason. Oh, there's got a screenshot of it. And likewise, if you look at your own IP address using one of these online servers, this is mine. I've got an IPv4 address, which we've talked about, but I've got an IPv6 address as well. So I'm running both IPv4 and IPv6. Ooh. Sorry, I've just lost my screen there. Oh, there we go. All right. And this is my, oh, Paul, put your hand up.
Yeah, it used to be, Peter, a long time ago when I was first doing the internet back in the 90s, you could slap in, particularly if the has gone down, because normally the DNS is run by your ISP, isn't it? If I'm right, or unless you're using a VPN or you're using a proxy, your ISP runs the VPN. Runs the DNS, and if the DNS is down, you used to be able to stick in the IP numbers, the IPv4 numbers at least, straight into the web address bar, and it would take you to Google if you'd made a record of what some of them were. But you don't seem to be able to do that on the browsers anymore. They just sit there when you slap in the digits. So what's the workaround for that?
It's actually fully working. You can do HTTPS:// and then an IP address.
Oh, so you have to put
Yeah.
okay, right. Because in the old days, I can remember just sticking the numbers in, and the browser automatically assumed you were just trying to go straight there and just took you there. So you've got to put.
So some of the browsers are trying to be a bit too clever for their own benefit. So you type in something, it thinks you're doing a search rather than actually telling what address
Right.
it is.
Yeah.
Um,
Okay.
just
Yeah.
a few things on that, because that's a good point. You can do the same thing with IPv6 addresses, like these ones here that I've got here, but you have to put them in square brackets. So HTTPS:// open square brackets, IPv6 address, close square brackets. A little bit weird. And you mentioned DNS servers. Yes, ISPs may often supply a DNS server. But of course, there's very common ones like Google's got a DNS server, which is 8.8.8.8, which you can use directly if you want to. People run DNS servers on their own network for caching and sort of like blocking type purposes.
Yeah, I think you have to. Mostly the browsers lock in, or at least they default to a certain DNS, don't they? And because I remember before when Virgin DNS kept going down, whether it was being hacked or whether they were just doing incompetent upgrades, I don't know. And I got around it, and I tried putting in the Google DNS, and I couldn't get to it. And in the end, I had to go and reconfigure the browser
All right. Okay.
and the firewall to do it,
Yeah.
because I think it
Well,
was kind of it was kind of
mm,
loaded in kind of thing when you first
yeah.
connected through the browser
Yeah.
through the router. And I think this is one of the problems. Sometimes knowing a little bit too much is dangerous, but also the bloody ISPs try to a lot of them do try to download all sorts of bloatware to your box, particularly if you're using Windows, which I was at the time, and that can really can go wrong at times, and it has repercussions as well. But I've noticed on the Appleware that I don't seem to get anything downloaded from my ISP, and the system just works as it should do.
Yeah. Yeah. I mean, sometimes ISPs try to be too helpful, you know. Um,
Well, they
oh,
certainly do on
oh,
phones sometimes, because as soon as you plug the SIM card in, they can try and dump stuff onto your phone. But depends what phone you're using.
yeah. So what I would always recommend. So when you use DNS, you have to give it a DNS server so your desktops can do this lookup. And the recommendation is usually you put more than one DNS IP address in. You put the IP address of the DNS server your ISP provides,
Yeah.
and then you put a secondary one, which is like Google or Cloudflare or something like that. And so, should your ISP's DNS service fail, or your machines on desktop will just carry on working because they'll use the second one.
Okay. And what you were referring to before with the CGNAT, if you're using a VPN to tunnel through, does that do CGNAT and DNS lookup for you, or does it route through IPv6 straight out into the internet?
You will effectively do in a VPN over CGNAT.
Right. Okay. And the endpoint where the VPN lands, the point where I'm going out to the internet as far as the internet's concerned,
Yep.
that will do the DNS for me, won't it, on that server?
Yes. So when you start your VPN software, it will configure you a new IP address for your desktop, which is set by the VPN server, and it'll also configure a DNS IP address, which is relevant to your VPN server.
Yeah. Okay. And there's one final thing on this. I'm sure you'll come on to it later, but there used to be problems with DNS poisoning, and the fact that they sort of replicate, don't they, out through the internet, so that if one goes down, they all catch up at some point. Is that still a modern issue, or does IPv6 solve a lot of that?
There's nothing in IPv6 that helps with that, but DNS these days is much more locked down. There's, DNS queries are usually now encrypted to, trusted servers which have got the right certificates installed and so on and so forth.
Right. Yeah. Because it certainly was a problem about 10 years ago, wasn't it?
Yeah.
Thank you.
Okay. Yeah, so this is my Mac, which is, the internet configuration. And scroll down a bit, you can see I've actually got several IPv6 addresses. Now that's pretty common. You will, if you're running IPv6, you'll have a IPv6 IP address, which is used to communicate with the outside world. You will have maybe one or two additional addresses, which is used for administration functions as well, which doesn't go out. And unfortunately, the Mac here doesn't actually tell you which one's which is a little bit hard. Um, Linux is actually a bit better. So this is a Linux way of looking at what is the IP address. And you can see I've got INET6 here. I've got its IPv6 address. And actually it does tell you that this particular address is global. So this is your what's called a public IPv6 address. And this other IPv6 address is for administration purposes only. Link local is what they call it. And finally, I think I've got a Windows version here. I mean, this is from my wife's Windows machine she uses for work. But exactly the same thing here. We've got IPv4 address assigned to this machine, and we've got an IPv6 address assigned to it as well. So big point here is that all operating systems now support IPv6. It's been around for such a long time, but somehow we don't tend to talk about it very, very often. Ray.
Yeah, with IP IPv6, as it's unique in the world on the internet, where do we stand with firewalls?
Ah, I'm glad you asked. What a good question. So, we'll come on to that shortly. I thought that was the next slide, but no, we'll come up definitely on that. Keep that in mind because it does simplify firewalls. So like IPv4, IPv6 has this CIDR notation. And it's similar to IPv4, and that is you've got a slash and a number of bits. So for example, this IPv6 address /48, 48 bits, which is the network, means we've got 48 bits for the network and 80 bits for the host part because we've got 128 bits in total. So in other words, this network has 2 to the 80 hosts or 1 septillion addresses on that particular single network, which is, if you write it out, which is, I'm not even going to read them out. This range of addresses, an awful lot of addresses. And as I was talking before, each host will get assigned, whether it's your desktop, your server, your firewall, or whatever, will have what's called a global IPv6 address. Now, with IPv4, your IP address is assigned by a DHCP server. For IPv6, it doesn't work that way. IPv6 addresses for your desktop are assigned using a system called stateless address auto configuration. So they figure out their own IPv6 address, and once it's determined, it stays fixed. And I mentioned before, you've got these admin IPv6 addresses. Those are used to negotiate what your personal IPv6 address is. Not going into details of that, other than saying you don't need a DHCP server. Hosts work out their own IPv6 address. There is a local host or a loopback address, which is 0000001 or ::1. And we do have these 1 or 2 additional IPv6 address, which is used for administration purposes. Now, ISPs, Virgin Media, City Fiber, BT Internet, and so on and so forth, get allocated IPv6 addresses, which is /32. So in other words, there's 32 bits for the network part and the remaining for the host part. So this is absolutely bonkers, huge numbers. So the ISPs, of course, need to then allocate that to businesses and consumers. Businesses are typically allocated a 48, so 48 bits of network addresses. And consumers, you and me, are allocated a 56 or a 64. So 56 bits of network or 64 bits. And we'll have a look at that, actually, what I get a little bit later. So what's the advantages of IPv6 over IPv4? The big one is vastly more addresses, bonkers. Yeah, you can't even begin to imagine how many unique addresses. So it solves the IPv4 problem that we've run out. But also it's a little bit more efficient. I didn't mention this. The what goes over the wire, the header is a little bit smaller, not hugely, but a little bit. Built into the IPv6 protocol is multicasting. In other words, you can send the same piece of data to multiple addresses. Streaming services make use of this. And they're self-configuring. So you've got a simplification that you don't need a DHCP server on your network. It's got IPsec by design, not a separate standard, which is used in VPNs. Big win is routers are simplified, which we'll look at. And in particular, coming back to your question, there is no need for network address translation at all with IPv6. There's very good support. It's been around for so long. My printer supports IPv6, my desktop supports IPv6, my servers, my TV, and so on and so forth. Everything supports IPv6. But and you can dual stack. We saw some screenshots. My Mac here has got both an IPv4 and IPv6 address. So modern ISPs. Most now, fiber to the premises being rolled out. And if you start to scratch beneath the surface, most of them are using CGNAT for IPv4. You might have to pay extra to bypass CGNAT to get your own allocated IPv4 address. But you should also get an IPv6 with a 56 range in it. So this means with this 56, you get 2 to the 56 network parts and 2 to 70 host parts. So every person, every consumer should get 4 septillion unique IP addresses that they can use on their home network. You're really not going to run out. I mean, I saw a guy on social media on the Fediverse yesterday, and he was saying, I wonder if I can create a unique IPv6 address to every pixel on my display. Why would he want to do that? But you can start playing around with these things. You just don't have a shortage of IP. So I've got a static IPv4 assigned to me by what is City Fiber, I suppose. And that's fixed. I have to pay for this. Bit painful. And I've got an IPv6 address range, which is in bold is the network part. And then after that, I can do whatever I like after that with a 56 range. And only one of those is exposed to the internet. And that's the IPv6 address, which I've exposed. And so finally, coming back to your question, Ray, Google.com's got a well-known IPv6 address. Your ISP will assign you a range of IPv6 addresses based on the network part. And then after that, you can do what you like. Your home router will use one IPv6 address on the public. And here's the big difference between IPv4 and IPv6. There is no NAT at all. Your desktop will get assigned an IPv6 address, which is guaranteed unique in the world. Okay. Whereas if you remember before, we had an IPv4 address, which we use, and my neighbors could use exactly the same home IPv4 addresses. Your IPv6 addresses are unique. So that means that Google.com can connect directly to my desktop. It knows the IPv6 address of my desktop. But of course, so I've got a web server on my network. And so I use NAT and port forwarding to convert. So if someone comes into plaw.co.uk over IPv4, they will get connected to this IPv4 address, and my home router will do what's called port forwarding and will forward any incoming packets to my web server. My web server will send it back to the originator, IPv4. IPv6 is completely different. My web server has got unique IPv6 address in the world. And what I configure on my router instead, I don't have to do this port forwarding. I just simply need to allow this address to go through. So firewalls don't have to do NAT. They just need to provide the firewall part of it, which is to allow or deny access to your internal devices. Hopefully that's clear. So I'm going to say it again. IPv4, for outgoing connections, you have to use NAT, which is expensive and complicated, doesn't work in all cases. If you're hosting a service, whether it's a web server or you've got voice over IP, telephony, you've got a SIP account, or you're doing gaming, for IPv4, you need to do this IPv4 forwarding, so inbound connections can come to your firewall, and your firewall knows to direct it to your particular service. For IPv6, much simpler. All you need to do, no NAT, no forwarding. You just simply need to allow particular packets to come in. So any question on that? Because that is quite important. Difference between IPv4 and IPv6. IPv6, there's enough addresses in the world for every single device, including your home devices, to have a unique number, and your firewall just simply needs to allow them through or not.
Can I understand that here, Peter, if I can? I've been given a digital line, fiber optic line now, and that comes with a new router, okay?
Yep.
Now, I'm just trying to understand what you're saying. Does it mean that my telephone number, which is done digitally, automatically has an IPv6 address?
The chances are that your home network has now got both IPv4 and IPv6 running in parallel.
Yep.
And chances are is whatever is managing your landline, as it were, just to distinguish it between mobile telephones, your landline also speaks IPv4 and IPv6.
Okay.
And your device will, there is a way, a NAT equivalent for telephony, and it's called a SIP proxy. So I bet your ISP has configured you a SIP proxy so that you don't need to do anything on your home network. It just plugs in and works.
Okay, but then if I go then to my firewall device, which is actually a Google home network.
Yep.
Now that obviously will talk. What will that talk in general? Will that be V6 or V4? What will it do at that point? My firewall device.
It'll be both.
It'll be both again, will it? Okay.
Yeah. Let me show you my my router. Oh, look at that. So I've got an ASUS router on, this is my, so one end is connected to fiber and the other end on my home network. And we can look at the LAN settings just to, maybe I'll make this make this a bit bigger. So LAN settings, so I've got a DHCP server for IPv4. You can see all the addresses here are IPv4. I don't need DHCP server for IPv6. We can have a look at, poke around on here a bit. We can see we've got port forwarding. Again, this is IPv4. So inbound connections, port 80 will get directed to my web server. And we can see here I've got, I don't, so my SIP is now over IPv6, but and we've got NAT settings, you know, in case you want to, again, this is IPv4, but I've got a separate button, which is IPv6. And here I can control my IPv6 settings, what my network address is. All of this is defaults. And if we have a look at the firewall settings, rather than doing this port forwarding for inbound, I've simply got allowing local IP addresses through, local IPv6 addresses through.
And what would you let through normally? Because obviously most of us don't let anything through.
That's right. The default for your firewall is to block any inbound messages, obviously for security, but allow any outgoing. So when you're browsing, you start a connection from your browser and talk to Google, and then you get a web page back. That's your outgoing connection, and it will, by default, it'll block any incoming connections. So a hacker won't be able to look at your devices on your network. That's what a firewall's there for.
Okay. The one thing which makes me a bit curious, obviously, all the kit uses DHCP to pick up the local addresses. Now, obviously, those usually have a range of 256 devices on them. Luckily, I haven't gone over 256 devices yet. It's a separate question. what would happen if I go above 256 devices? I've often wondered what would happen.
Yeah, so what would happen if you had more than 256 devices is that any new device wouldn't be able to join the network. It wouldn't work.
Wouldn't work. Simple as that. Okay.
Simply.
Is there
So
anything I
when you
can do?
so when you turn it on, when you turn your device on, it does a for IPv4, your device will do a broadcast saying, "What's my IP address?" And at that point, your DHCP server will say, "Nope, run out. You don't get one." So IPv4 will not work on that device.
What would I have to do to switch to V6 in this case? Because obviously I don't have this address limitation you're telling
Um,
me. So
yeah, you'll probably find IPv6 will work anyway. Will work without doing anything else. You go into that device, go into its configuration screens, and you'll probably see an IPv4 address that's been assigned, and you'll more than likely also see an IPv6 address.
but the thing which is puzzling me, how does the device know to use a V6 or a V4 address is what's puzzling me a little bit here.
Yep, good question. So browsers and other applications will typically try IPv6 first. And if that fails,
Um,
then try IPv4.
oh, thank you. A lot of questions there. Thanks very much. I'm taking a lot of time. Thanks for your help.
Okay.
Thank you.
All right. I'm just going to go in order here. John.
I'm not sure which John. There could be 10 of us in from
Oh,
past two
sorry.
Johns. Yeah,
I actually meant the other John, but yeah, you go ahead since you started talking. Why
you
not?
sure? Okay. Well, I obviously use IPv4 at the moment, and I use DHCP server with static IP addresses on the LAN, i.e., the I think you called them the NAT addresses. So obviously I do port forwarding, say for the web server computer. Now, what on IPv6, on the current IPv4, on each computer, say the web server, I allow UFW, which is the Linux uncomplicated firewall, to only allow certain ports. So, for instance, port 80 for the standard web server, and similarly for other functions. Would that all go with IPv6? Would all that disappear? Would there be a need
Um,
for?
so you IPv4 requires NAT in your firewall box in your router to convert really between your local IPv4 addresses and the public IPv4 addresses. Also, your router is acting as a firewall to block nasty inbound connections. So your router is a multi-purpose device. It's doing that and it's acting as a firewall. With IPv6, you don't need a NAT, so you don't have to configure that part. You still need a firewall. You still need to say your particular IPv6 address of your web server, inbound traffic to that address is allowed. And I did show that on my own settings here on my firewall. Sorry, on firewall settings. And so I've got port 80 and 443, and it's allowed in. So this is the IPv6 address of my web server, and that address is already unique in the world. And so I just need to say the firewall, let traffic in, any inbound traffic, let it come straight through. No NAT, no address translation going on here, only the firewall, only the secure part of it.
Okay, thank you. One other sort of corollary to that, I've got a private VPN on the Raspberry Pi. So obviously there's no outgoing from the Raspberry Pi to the device that wants to sign into it from outside signing in. Well, so that's inbound. So but the firewall still allows it, even though it's just an inbound traffic through the firewall.
Yes, so if you're running if you're running a VPN server at home, so you can access your device at home when you're away, which is what I think you're saying.
Yes.
Your VPN server could run over IPv4 or IPv6 or both. So if you want to connect to your VPN server over IPv4, your firewall needs to be configured to forward that port to whatever host is running your VPN server. For IPv6, it just simply needs to allow those packets through, whatever the IPv6 address is of your VPN server. And actually, I do the same. I do exactly the same.
Okay, thank you. Thank you, Peter.
So the other John, since we
Okay, that's me, I think.
sorry.
Yeah, a simple question. I mean, having looked at the IP configuration and so on, I can see I've got IPv4 and IPv6 available on my laptop at least.
Hmm?
How can I see for each session, whether it's a browser session or a Zoom session or whatever, which it's actually using in practice?
Yes, that's a good question. So I actually struggled to do that myself. And because, of course, your browser is just going to look up google.com and it'll convert that first to an IPv6 address, and then your browser would use that. And as far as you're concerned, you're just using google.com, even though your browser is using IPv6. There is a way in your browser to disable IPv6, and that can be useful to try and figure it out. Otherwise, you're back sniffing the network with something like Wireshark. So I don't have a good way to know from the outside if a given application is using IPv4 or IPv6. You have to get, dust off your network tools and try sniffing the network or see what connections are open depending on your operating system.
Thank you. Surprising answer, but thank you.
Yeah. Okay, so let's go to Paul. Okay, so Paul.
Yeah, I've got it. Yeah, sorry, the screen had gone. Yeah, is it a bad thing having a fixed IP address? And is it for each session, or is it for each instance of something that you're running, or is there a way to get it to dynamically allocate?
IP addresses are assigned to devices, not applications.
Oh, right. So once you get an IPv6 assigned to your device, you're stuck with it, are you?
You can configure it, right? But it's easiest to let it configure itself because then it's more likely to work. So if you fire up your laptop for the first time, it will negotiate this IPv6 address and then stay there. You shut your desktop down, start it up again, it'll have the same IPv6 address.
That, to me, with a defensive hat on, seems to be quite bad from a number of respects in terms of market tracking, various overseas, shall we say, state actors tracking you, and from a hacking point of view. And also, if you happen to get yourself blacklisted for some reason, it might not actually be your box that did it, but somebody impersonating you. What's the quick way to flush that? Or is it a question of tampering with it? Because I can see there's benefits for it, but there's also a lot of disbenefits, because that was one of the reasons not the only reason they went for dynamic IP addressing or allocation a long time ago, because having a fixed address had its positive points, but it also had its serious drawbacks as well.
Yeah, it's a good point. So first of all, I don't think anyone can spoof your IPv6 address because it just wouldn't work. Because everyone's unique in the world, they can't just take over your one IP address on your ISP's network. It's just routing and such like just isn't going to work because
they could if you're switched off, because effectively all you're doing is playing around with headers and other sorts of things like that, aren't you? And pretending to be
yes,
that person.
you can create a packet to your IPv6 address, but it wouldn't get to you. It wouldn't go to anyone else.
Right.
It just would fail to work. You get no response.
Yeah. Okay. It would depend. It would depend on. I won't say too much, but it would depend on what level of network access you had. if you're overseas in a, shall we say, semi-hostile country with your phone or your laptop or whatever, you could be having problems there. But what I'm also concerned about is if people learn what your IPv6 address is, that can make you a kind of a static target, can't it?
Yeah, absolutely. I mean, that is a good point. If you've got an IP address which is IPv6 address which is fixed, then yeah, absolutely, that could be used to identify you in the same way as people use IPv4 addresses and fingerprinting of browsers and all the rest of it.
Yeah, but then again, if you are using a VPN or a proxy, then that is hidden from things that are upstream of that, isn't it?
Yeah, I mean, if you're using a VPN, you've still got a public IP address, of course, but it's likely to be shared across large numbers of users.
Yeah, so that's effectively where the boundary is. But inside of that, if people can get in at that level, then you are slightly more exposed. But in terms of the general internet, if you're using something like a VPN or even your ISP to a certain extent, you are that is the attack surface, isn't it, from what the external world sees?
Yeah, I mean, I should look that up, to be honest. Yeah, a better response on the
Yeah.
tracking issue. I mean, I've not been reading about it. I've not come across that particular concern. So, but it seems to be quite a valid concern. I should look it up.
Well, it's a valid. I mean, just as an aside, it's a valid concern for anybody who's, say, an academic who's complained about Trump cutting the funding at certain university research projects, etc., and they happen to get stopped at the U.S. border. That's a legal issue, but it effectively makes it very hard to. Well, there's no plausible deniability that you said something when it's that trackable. Even if it's quite an innocent mark to remark to have said. It can still have huge repercussions in the future.
Okay. Yeah, perhaps you'll follow that up on the forum. Neil.
Some of that about the what could be done with 6 may have sort of done it. But as I'm probably one of the least tech savvy of any of you about this, when you were talking about this, it did seem to strike me that unless there are bits of the accessible network or whatever you want to do, are there still bits which only have IPv4? And what you were describing, it sounded as though really everybody had access to IPv6, and I was really going to say, why is it that actually, as it sounds a darn sight more efficient, why is it hasn't just evolved into it being the standard now? So what am I actually missing?
Yeah, so yeah, good point. So I've got a slide on that, which I just fast forwarded to. So in theory, just to kind of come back, if your ISP supports IPv6, then in theory you could turn off IPv4. And sure enough, techies of this world have been campaigning for this for years because of this shortage of addresses on IPv4. Now I did some research. IPv6 is only used by about a quarter of the websites in the world. So the big ones, of course, all use IPv6. I mean, that 26% is a bit misleading. I would say it better as all the big ones support it. A lot of smaller ones don't. That's just a simple count. So U3A UK, IPv4 only. U3A communities, IPv4 and IPv6. My address, IPv4 and IPv6. And in my logs, I see about 20% of incoming connections are from IPv6 clients. And U3A communities a little bit less than that. So you're absolutely right that although it is possible to turn off IPv4, and it's also possible to use an IPv6 to IPv4 translator, realistically, we're stuck with IPv4 as a dual stack to access these big servers only that still only support IPv4. But as we said before, browsers will try IPv6 first and then drop back to IPv4. So yes, it'd be a nice thing to turn off IPv4, but it ain't going to happen anytime soon because a lot of the public web servers just don't support it yet.
If I can just drop a small pebble in the pond, I've just discovered that I'm with Virgin Media and they don't support IPv6.
Yep, I used to be on Virgin Media, and that was one of the reasons I left. Okay, so I'm going to, sorry if you've been hanging around a long time. So I'm going to go to John Rose next. Oh, John seemed to have gone from my list.
He's muted.
We can't hear you, John.
No, no, Peter, I asked questions before. Remember, there's confusion over too many Johns, and I forgot to lower my hand.
Oh, okay, fair enough. Thank you. Thank you. Adrian.
Right. I've got a couple of quick questions, one about DNS servers and one about firewalls, because you've related to them both. Okay. You say my ISP has a DNS server. If I look in my router, it also has DNS servers. Is that supplied by the ISP? I assume that is the same as theirs, but I could change those. And I can also change them on my computer. So what's the relevance of having different ones there and which takes precedence?
Yeah, good question. So what happens is that when you turn your router on, it wouldn't have been configured with a IPv4 or IPv6 address. When you turn it on, it goes through a process of discovering with your ISP, typically using DHCP. And that process also assigns a DNS address to your router. So there's a default, if you like, or there's usually a setting in your routers. Do you want to use the DNS server provided by your ISP? In which case, yes, and your router will pick that up by DHCP. Once your router's got the DNS server, then it will offer the same address to all the devices on your network. So first, your router gets the IP address of the DNS server, and then secondly, your router gives it out to all the devices on your network. Absolutely, you're correct. If you don't want to do that, you can do two things. You can either stop or override the DNS settings given to you by your ISP, or you can go in the DHCP configuration of your router and say, well, instead of using this ISP address, use this one instead. And what the recommendation is to have at least one DNS server given out. Perhaps the first one is a DNS server your ISP is giving you, and maybe the second one is one of the big popular ones like Google or Cloudflare and so on. And devices actually behave differently with if they're given more than one DNS server. Some devices will just load balance it. So the first lookup, it will use the first DNS, and then the second lookup will use the second one, and the third one, it will go back to the first DNS IP address. And so it will load balance them. Other devices will always use the first one, and if the first one fails, then go to the second one. So lots of devices behave very differently if they're given more than one DNS address.
Now, what if I set them on the computer as well? Because I have the option on the computer to do
Yep,
that.
you've got the option to manually override that on your computer if you want to.
So which takes precedence? The computer then at that stage?
When you turn your computer on, it will typically use DHCP to discover its IP address and DNS servers. And once it's discovered it, you can go in there and remove the DNS server that's been auto set and set whichever one it likes. And then from that point onwards, you'll only use the new one rather than the old one.
Okay, now I actually have a motorhome and I have a 4G router there. And I took my laptop and I had set DNS servers on the laptop, I think to be Google or whatever. And it worked perfectly and worked on other devices. But when I took my laptop, it wouldn't connect up via my 4G router. I deleted the DNS servers on the laptop and immediately connected up. Why would that be?
Don't know offhand. Let's see if I've got it on here. So this is the DHCP server running on my firewall. And so the main purpose of DHCP server is to give out IPv4 addresses. But you'll also see I've got the option to set two DNS servers. And these are given to devices when they connect in. And that's the way, to be honest, the way I would configure it is have a look at your 4G router, configure the DNS server on your 4G router, which will be 8.8.8, and then don't have any manual configurations on your notebook. So you're on your motorhome, you turn the notebook on, it will get an IP address from your 4G router and it'll get a DNS server which is suitable for your caravan home and it'll just work. So it's nice to try and keep individual desktops automatically configured, but make sure you configure your routers, which is appropriate for their circumstances.
Thank you. My other query was regarding firewalls. What's the difference between a hardware firewall and a software firewall? And it seems that some people suggest you need two or both.
All firewalls these days are, written in software. Whether you've got a router like I've got from Asus, my Asus happens to run Linux, I happen to know, and it's got some software in there which manages all the firewall rules. So the firewall is always in software. What I suspect the difference is should you have a firewall on your router, and should you also have a firewall on your desktops? Because things like my Mac, I can go in and configure a firewall which is on my Mac. On Linux, I can enable a firewall. On Windows, you can enable a firewall. What I personally do is rely on a good, well-configured firewall on my router, and I don't then have an additional firewall on my desktops, on my individual machines. You honestly just need one.
But I do see hardware firewalls advertised. What are they for?
I suspect they are just
Are they for businesses?
routers. I've not seen the term myself.
Okay.
Maybe you got a reference to it, but I suspect that they're talking about firewalls running on physical hardware devices rather than a firewall on your desktop. Both of them are software. Bit of a strange distinction, really.
Thank you.
Okay, Peter again.
Okay. Will thread always be v6?
Can you say that again?
Will thread always be v6?
Thread?
Yes, my local home device with the new devices, or my local home devices, were they the thread devices, which I can get? Okay.
Oh, thread. Okay, yeah.
Now, will they all be v6, or what will happen there, please?
Yes, I happen to know that the thread standards for IoT devices in the home is actually based around the IPv6 standard.
Okay.
They should, as far as I can remember, also support IPv4, but it's a very modern standard, so absolutely it will support both IPv4 and IPv6.
Because if anything's going to run out of addresses, it's the local devices.
Exactly. Yeah.
The second thing, I tend to use Fing to try and work out what's happening. Can you recommend? I used to think an app called Fing, Fing.
Yeah, we made it. Honestly, we made it.
Do you have an app which you might recommend to see what's going on my network with a new standard at all, please?
Yeah, I mean, I've got a Fing hardware device on my network actually.
Okay, yeah.
Was part of the original Kickstarter campaign for Fing. And if you don't know, Fing is it's a little blue box that sits on your network and it listens to Wi-Fi and stuff and can actually block devices dynamically. It uses some quite clever techniques to try and protect your network. So yes, Fing can be useful for these things. If you're looking at seeing what network packets are going over, you can use tools like Wireshark, which will open up and listen to all the traffic on your network, both IPv4 and IPv6, and in fact non-IP traffic as well. Um, that's probably it. I mean, operating systems will have their own little tools to display the IP addresses and settings and such like, obviously.
Okay, thank you. Thank you.
Neil.
Hi there. A couple of questions. So you briefly mentioned multicast as being part of the V6 standards.
Yep.
What's multicast ever implemented on V4 that you're aware?
Yes, multicast is implemented, but it's a separate standard. That's a big difference. So with IPv6 is part of what IPv6 means. And with IPv4, the multicast is a separate standard managed in a different way. That's a distinction, really. In other words, IPv6 has been designed with multicast in mind, whereas IPv4 wasn't.
Okay, that unfortunately makes sense.
Okay. So I think I actually completed. I did have to tackle maybe.
Hang on, one more question, if I may.
Yeah.
What method would you suggest for detecting whether you're behind a carrier grade NATS system?
Oh, well, that is often a challenge. So if you do go on to what's my IP address,
Yep.
there's loads of them available, and I think if you do a Google search, it'll tell you as well. If you end up with an address beginning with 10, you're on CGNAT.
Okay, I thought that V4 standard had 100 as the CGNAT.
It could be 100 as well.
Okay.
Might have to look it up. I've got a slide here somewhere, haven't I? Well, maybe I'll just exit from there. Oh yeah, that's
okay.
the
So
slide I was thinking of.
that's the one, yeah. Okay, I can go look it up as well. It's
Yeah. So in this case, the CGNAT has given me, or this example, a 10 address. But there are ranges. There's several ranges of the IPv4 which is allocated for private use, and a 10 is one of them, and you say 100 is another one of them. I think there's like 3 or 4 of them. So if you go to that website, which and my IP address, and it's one of these 10 or 100 addresses, you're pretty much sure you're on CGNAT. The ISP is trying to hide things from you.
right. Okay, thanks.
Okay. So I'm sorry, I've not gone through my slides in logical forwards order as I normally do. But I did get to the end of the slides. If there's anything else that you want to look at, you can play around. I've got in the end of the slides is some references with some of the websites I've mentioned. Okay, so let me tell you what, let me stop sharing. So anything else from anyone else, whether about IPv4, IPv6? Any suggestions for our next meeting before we sign off? We had one vote for local generative AI settings.
Yeah, I'll vote for that as well.
Okay.
I'm halfway through trying to get things set up.
All right, so
do with some hints.
That's probably already enough to determine what we're going to talk about next week. Damn, I've got some work to do now.
Can I fire a general query?
Say that again, Ray?
Yeah, can I fire a general query?
Yeah, sure.
Yeah. Anybody here got Virgin Media with a Hub 5?
Thank you.
What,
yeah, I have, bro. Yeah.
Because I've just been given one a few days ago and installed it, etc. And whilst it now downloads the faster speed, which is what I was after, the upload is
is not particularly
good.
brilliant. No.
Yeah, I can answer that one actually. Virgin Media, we're over coax, what they call cable modem, using the DOCSIS standards. The download speed is always pretty much a tenth of the upload speed. It's the way they advertise
the other way around.
Upload
speed.
Upload is 1/10 of download. Yeah, sorry.
Yeah.
That's the way Virgin Media work.
But in my case, I'm not even achieving the 100 megabits. It's sometimes running around 50, 40, etc. And I just wonder if it's a quirk with this Hub 5 modem, because my Hub 4 was no problems, or whether I got a problem with my network configuration.
Yeah, I would recommend testing with Ethernet first.
Yeah, well, that's what I'm using primarily.
Okay. Yeah.
And in fact, it's strange enough, something I would never have thought I would seen, but the Wi-Fi actually runs better than the Ethernet.
I would look at to see if you've got problems with your cables.
Yeah, I did wonder.
I did have myself. I had a problem actually on the Thing box. Peter was talking about Thing. The Thing box was reporting I could only have it was a 10 base T connection. I just thought it was limitation of the Thing box, but I changed the cable and suddenly it was 10 times faster.
Okay, right, yeah.
I
Well,
do. Yeah, I do on my network automate testing. So I'm on a fiber connection over City Fiber and actually use Tube. And we can see I'm pretty much 900 meg both upload and download. And occasionally it dips down and the latency is around pretty much around about 4 milliseconds.
Oh, I'm jealous. You got 900 both ways. That's what I'm trying to get. Doesn't exist down here.
Have they fiber optic your road yet, Ray? They put fiber optic down your road?
Yeah, PT has put fiber optic down the road, but all the deals I can find so far are 900 stroke 100.
So you've got coax into your house.
My Virgin Media is coax to the house
Yeah,
at the moment.
yeah. You always want to get this 10-to-1 mapping with Virgin Media.
Yeah.
It's part of the standards.
But I'm not even getting 100 megabits. It's gone slower. But you reckon, Neil, yours is doing the same. The upload is iffy.
Yeah. Mine's usually just over 100, but it does drop to 70 on on the upload. Yeah.
Okay. More or less the same. Yeah, was my Hub 4 had none of this problem.
No.
Out of interest, I've just had Vodafone put in over fiber optic. It went pretty smoothly. City Fiber did the work, but it's a Vodafone contract. They charged me 23 quid a month for 90 meg. It's both ways, like Peter's saying. It's 90 meg up and 90 meg down. So it's pretty consistent over fiber optic. It was pretty smooth. The contract lasts 2 years. I think there's an uplift next April, as always. Just to know if you're stuck with Virgin, maybe you should think about switching suppliers if you got fiber.
Yeah, well, I was looking at Vodafone, but they were still offering me 910 stroke 100. They weren't doing the symmetrical up down speeds.
Vodafone is definitely symmetrical as far as I'm concerned in Reading, so that's for sure.
Yeah, well, I'm down here in the sticks in West Wales, so it might be a bit different.
There's always those sort of problems. I suspect it's pretty equal because I guess the technology they're using is probably going to be roughly the same. I don't see why, if the fiber optics laid to your premises, I would have thought it would be pretty equal. So I don't know. I would have thought it was equal.
No, there's only one provider around in this area doing the symmetrical one. That's U-Fiber, but they're in Trowbridge main town. I'm out in the mile and a half out of Trowbridge, and they're not supplying out here at the moment. So anyway, okay, thank you.
Yes, since this question came up, I did write up my personal experiences with ISP. So if you go on plaw.co.uk, I've got a link here, ISPs, and I've got my findings with Virgin Media, Link broadbands over City Fiber, Force Utilities over City Fiber, and finally Tube. And my big recommendation for anyone thinking about changing ISPs is that you'll always get a grace period of maybe 3 or 4 weeks. And my strong recommendation is during that 3 or 4 weeks, do as much testing as you possibly can. And if you find you get poor performance, switch before you get locked into 2 years. So for example, I found Link broadbands was incredibly poor in the evenings. You can see here that in the evenings, it just dropped down every single day. It dropped down in the evenings. And now with Tube, it's like rock steady now, even though it's the same piece of fiber into my house. So I did write up my findings there, and I've got some my little price list here of the price comparisons.
Okay,
So that was
what were you using to do the speed test? You must have automated it, have you?
Oh yes, yeah. Yeah, I automate it in Home Assistant and using the standard speed test from, was it Okia or something like that? But
Oh, Ookla, yeah.
Yeah. Yeah, I manage this on my Home Assistant. You can see large speed test.
Okay, right. Thank you. Interesting.
Sorry, I didn't mean to go into that, but since you raised it. All right. Anything else? For anyone else? So next month we'll do Zoom straight away. Or we might come back to this big blue button another time.
Good. Thank you very much, Peter, as always. Very good.
All right.
Thank you.
Thanks.
Yeah,
Thank you very much.
Thanks ever so much. Yeah, fantastic. Yeah.
See you later.
Good.
Bye.
See you later.
Bye then.
Thanks, Peter. Thanks, bye bye.
Yeah,
Bye bye.
excellent. Thank you.